Hi everyone, we are Interface Biosciences and we are defining the future of microbiome therapeutics. My name is hwastyk. I'm a bioengineering PhD at Stanford and co-founder. Will Van Churen is also a co-founder and a recently graduated PhD from Stanford's microbiology and immunology department. We are led by our PI, Justin Sonnenberg, a tenured professor at Stanford with over 20 years of microbiome experience. Now, I'm sure you've heard of the microbiome before, which is that collection of trillions of microbes that live in and on our body, mainly in our intestine. An explosion of research in the past 5 to 10 years has implicated the microbiome in promoting health and disease in nearly every organ system, as well as drug metabolism. Because it plays a major role in almost half the leading causes of death in the US, there's a huge opportunity to identify drugs or therapeutics by better understanding the microbiome. Unsurprisingly, corporations have invested over $3 billion in microbiome research in the last decade, with worldwide milestone payments eclipsing $5.4 billion. Even without approved drugs, microbiome companies are securing billion-dollar deals with pharmaceutical partners. The current approach used by these first-generation companies is to give a live microbe as a therapy. These are known as live biotherapeutics, and while they have had some successes, they also have some serious commercial risks. First, they have limited discovery process due to noisy samples and a small search space. Second, they have serious commercial risks, including high expense to manufacture, unpredictable efficacy based on a person's diet, lifestyle, genetics, and finally, a much smaller patient pool relative to a traditional pharmaceutical. Despite significant research, no live biotherapeutic has been approved by the FDA. These companies are pursuing the wrong approach because they're missing the most important part of the picture. When we showed you this before, we used the level of detail people focus on today, which is that microbes create some sort of human cell response. What we didn't mention, however, is the most important part: the chemicals, otherwise known as metabolites, that these microbes produce. These metabolites are small enough to pass through the mucosal layer, enter our systemic circulation, and alter human cell behavior. Interface Bio has the solution to this microbiome therapeutics problem. We focus on the metabolites instead of the microbes. We are a drug discovery engine that identifies the chemical reasons microbes help people and apply those to solving many different diseases. I'm going to let Will take it away and talk about how we do it.
So first, we exercise the full chemical potential of hundreds of individual microbes. Then we use systems immunology to identify the immune phenotype introduced by each metabolite we measure. Finally, we select metabolites that support immune phenotypes and demonstrate in vivo activity. In total, our pipeline allows us to mine the microbe for novel immunomodulatory chemicals that can be developed as traditional small molecule therapeutics. The database we generate is an unparalleled biochemical resource that only we can mine and develop. Here we're showing the most comprehensive strain metabolic map in existence that we've generated. This map shows chemical production and consumption for over 200 different strains. Each of the rows is a strain and each column is a metabolite, numbering over 400 known metabolites and 2,000 unknown molecular features. The ability to research and identify candidate metabolites is scalable and benefits from network effects. Our approach takes advantage of predictable pharmaceutical chemistry rather than trying to modify entire microbiomes. We'll show you how this database enables anti-PD-1 immunotherapy enhancing metabolites with some proof of concept data. First, a little background. Immunotherapies are breakthrough treatments that have led to significant advances in cancer therapy success, but they only work in 12% of eligible patients. Recent research has shown that the difference between the responders and non-responders to immunotherapies are their gut microbes. Some metabolite that a microbe is making is improving treatment success, but no one's identified it yet, which prevents effective expansion of the immunotherapy patient pool. We can use the Interface Bio data to identify these metabolites. The heat map we showed you before is data on 200 strains, including 4 that are known to support immunotherapies. By comparing strains that support immunotherapy to those that don't, we can identify potential causal metabolites. The 40 most likely metabolites are shown here as red diamonds. This screening process is unique to Interface and gives us a way to rapidly hone in on the key microbial metabolites responsible for a phenotype that we can further develop. Our plan is to continue to build our high throughput pipeline to expand our database in all 3 dimensions over the next 18 months. We're going to build out the data for the first application we've shown you, immunotherapy supporting metabolites, at the same time. As a drug discovery engine, we can continually identify therapeutics within the microbial chemical space across a range of diseases and treatment modalities. We're looking for the right partners as we grow and define the future of microbiome therapeutics.
We hope to hear from you soon.